In this video, we're going to look at the solution for Review Activity 10-1, and we're asked to find the MMC and LMC, that's the maximum material condition for a hole and a shaft, and the least material condition for both a hole and a shaft. They're asking us to do this using the lookup table, figure 10.7 for values. Normally you would use the machinist's handbook, but that is another class. We're just doing the basics right now. They're asking us to do everything to 4 decimal places of accuracy. So let's go ahead and get started and see how to do one of these problems. So diameter A, this is the diameter of both the shaft and the hole, the nominal diameter or the basic size of the hole. And 5/8 first needs to be converted to a decimal. And you can look that up on the chart. If you have a handy dandy decimal chart, there's one in your appendix. 5/8 is 0.625. Or you can do it on your calculator, or you can just memorize 5/8 is 0.625. Then what I need to do is I need to go to figure 10 or table 10.7. I need to find out where 0.625 lies. And 0.6 is between 0.4 and 0.7. Then I need to go to the fit column, and we're fit RC3. Then I need to come down and find the values for the hole and the shaft. It's also worth pointing out, to save space on this table, all the limits are specified in thousandths of an inch, or in thou. So this would be like 6/10 of a thou. This would be 1 thou. And what I've done to make this easier for us, I have turned on that little bit of the chart. I've put it in right here. And we'll go ahead and start by putting in our values. So to begin, what I'll do is I'll put 0.625, 0.625, 0.625, 0.625 in for everything, because that's my nominal size all the way across. So let's start by with the hole. Which of these two values will give you my maximum material condition? If I take the hole and I add 7/10 of a thou to it, the hole will get bigger and the amount of material will get smaller. And if I add nothing to it, the hole will stay the same size it is. So the 0.7 is going to be my least material condition, and I'll write it like this: 0.0003 3 decimal places and then my 7. And that'll be equal to 0.6257. And in this case here, I will add 0, and that will be equal to 0.6250, because I have to work everything out to 4 decimal places. Okay. So just one more time, as you make the hole bigger, there's less material. Okay. The shaft is opposite. As the diameter of the shaft gets larger, there's more material. So if I subtract either of these two values from the shaft, which one will give me the maximum material condition, or the largest diameter shaft? And that's going to be the 0.6. So I'll do 0.0006. And then this is just simply going to be 1 thou right here. And I'll finish up the math. And sorry about the graphics tablet. This is my first time using it to make a video, and I'm learning how to write on it. Okay. So this number here is bigger than that number there. So for the shaft, I chose correctly. That is my maximum material condition. This is smaller. Oh, I need a 0 right there. I need 4 decimal places. You can see that's clearly smaller. So that's my least material condition. That's a quick check you can do. And then my allowance is going to be the maximum material condition, or the MMC condition, of the external feature minus the MMC of the internal feature. So I'll do MMC of the hole minus the MMC of the shaft. And 6250 minus 0.6244 is going to be equal to 0.0006. And that'll be my allowance. And that means that when the shaft is inserted in the hole, how much daylight, or how much room for daylight, I have around the shaft to shine through. So that's how you work out these problems. Just to review, convert this to a decimal. Look the decimal up in table 10.7 and make sure you're in the right class of fit column. The next problem is going to ask you to do an RC2, then RC4, RC1, and RC2. So I hope this helps with these problems, and I hope that clears up a little bit about the MMC between the hole and the shaft.